Okay, so this week we are going to go over three categories. We're going to talk about title, we're going to talk about a new term that we're coining for our compute paradigm that we're pushing, and we're going to talk a little about the first computer system that we're building. With title, what we have right now is we have an interface to write and execute code, but that's it. We need to add two big things. One is the hardware simulator that lets you have a look and see what's going on the hardware side. And the other is AI. In we have to figure out how to get a model inside of title and give you the ability to train and inference that model. That is very important, and it's a big ask, but it's something that we can definitely do. It's not more difficult than what we have already done. So title needs to get a lot stronger, and it's important that we get it to a place where it is a very a high quality, reliably working professional application, and then we can add these two huge features that are going to make it a full simulation model. Because in order to get people to understand and in order to get people excited about this stuff, we need a simulation, a rock hard simulation, and we need a rock hard emulation. Now, simulation is showing what properties we expect and that we want to play with. So a simulation is more showing you exactly how we feel it's going to work. And an emulation is more of showing some of the physical benefits by using different physical approaches. So we have a new term that we're coining. It's called Cogent Computing. And the reason that we chose this word is that, frankly, all the other words that touch on our logic-based renewal they're not good. They don't roll off the tongue very well. Cogent was chosen because of its meaning towards it's used often for convincing, it's used often in legal terms, but the area that we like the best about it is that it means very logical. It's a little more, it's a step up from just the word logical. That means very logical. And that's perfect for us because what we're doing at a machine code level is adding an extra state of logic to the system to improve its capabilities and expand the potential of systems to communicate to themselves. That's the biggest thing. We're removing a bottleneck from the computer. We're not removing bottlenecks between people and the computers, which means that we're focused on software. We're focused on the chasm between software and hardware. AI has to tell the hardware what to do, and it also has to get instructions from the software to know what to tell the hardware what to do. When we make that area more descriptive and we increase the sophistication of our AI at that level, that is where we increase the intelligence. Just increasing speed does not increase intelligence. So this is why we chose to coin this paradigm of enhanced logic systems with the word cogent. So cogent computing is the field that we focus on for AI right now. We plan on expanding from there in the future, but this is getting our foot in the door in the technology industry and the AI industry at large. Okay, so the first computer system, the first emulation that we are building as a company, the placeholder name for that system is Mark 1, the Mark 1. And right now it's bridging the gap between now and at the tail end 2035. So the technology that we need to come to fruition for us to make the real thing, right? And that will be done in Mark 2. We need a technology that is currently predicted on a roadmap for TSMC, IMEC, these huge semiconductor companies, semiconductor component manufacturing companies, as far as early as 2029, which is a little too soon for where it's at right now. all the way to 2035. So the technology that we need to make Mark II, to make the real deal Cogent computing system, is 10 years out. And so we're bridging the gap with a computer system that a Mark II could show 70, 100x energy consumption and efficiency improvements, right? Mark I, because it will be using current technology to emulate what we really would love to have, we're probably only going to see 5 to 10x improvements, which is a shame, but you have to look at it like this. Imagine Mark II is a fresh 25-year-old finance major going to a bank and setting up an account, right? They have no problem talking. They know all the terminology. They know they ask them to sign up on the Chase app on their phone. It takes them 2 seconds. They know how phones work. They're tight in with tech and they're tight in with finance. They know exactly how to work with this guy. The meeting ends in 10 minutes, right? And what we have right now is a senior citizen with our computer systems. A senior citizen goes into a bank and it takes them forever to get to the point. It takes them forever to understand the terminology. You ask them to sign up on the Chase app on their phone. They barely know how to use their phone, so it's taking them forever. Now, what the Mark I does is bridges these two. It finds a way to get to that 25-year-old fresh out of college finance major who is plugged in with tech and is like this. In order to bridge that gap, imagine a parent going in. The Mark I is an older parent going into the bank and talking with the banker, understanding enough to understand what they're doing with setting up their account. And then the banker asks, can you please sign up on your phone for the Chase app? And normally the parent would say, I need my glasses. I'm not really sure how this works. I have to download it. I don't remember my password. I don't know how to get on the Wi-Fi here, right? But with the Mark I, the parent walks in with their kid, right? Their teenage kid. And whenever that banker says anything about tech and they ask him to sign up on their phone, they just hand the phone to the kid. The kid logs into Wi-Fi. The kid knows all their parents' passwords better than they do. They log into the bank app. They just ask their parent, what email do you want to use? They sign them in. They throw in their parents' phone number. They throw in the address. They sign up like this, that. And then they hand the phone back. So that's what our Mark I does. What our Mark I does is it allows the lowest level machine code language to still operate, because that is the hardware we have to use. We just have to use it. And that will do everything. That will schedule the meeting with the banker. That will talk the talk and sign the papers. But once the phone has to be logged in and we have to download the app and we have to sign up, once large arithmetic operations have to be executed, that's when we go to an emulated level. We go a level above the hardware and we emulate how we would like hardware to operate. And so we use the hardware to do parts of the operation, but then we jump up to this emulation to perform the arithmetic calculation, and we shoot the result that is needed to continue this logic sequence back down to the hardware. So the hardware gives its phone away, they get all logged in and all set up, and they take the phone back. And it is much, much faster than if the conventional technology assumed that responsibility on its own. Instead, it traded responsibility. And this is perfect because it quite literally is a handoff. We're handing the baton, and this is an evolution of computing. It is not so much a paradigm shift as it is a modest evolution of technology.